The focus standard for today's lesson is from Grade 8 Functions, Standard A, Define, Evaluate, and Compare Functions. The topic for this lesson is from our Mathematical Models unit, Linear Graphs. Our central question is, when describing a linear relationship, what are the important characteristics to include? So please take a moment, making sure that your header is complete. You have the date, set up your question column, and your note column. So, in the last video we talked about the two different types of relationships being linear or nonlinear, and today we're going to focus on just linear relationships. And in fact, that will be our focus for most of this year. So with linear relationships, we basically want to ask ourselves three questions. Is it increasing or decreasing? How steep is the line? And what is the starting value? By asking these three questions, we can really get a lot of information and then use that to continue to explore the mathematical model that we're looking at. So today I'd like us to create two graphs. And for simplicity's sake, I've just titled them Graph A and Graph B, although there's enough information we probably could have given a more specific title. So in Graph A, and we're being asked to compare and contrast these two graphs. In Graph A, on the x-axis, we're looking at time spent shopping in hours compared to the amount of money that we have. In Graph B, we're looking at time spent working in hours on our x-axis compared to the amount of money that we have graphed on the y-axis. So take a few moments and just think about those three questions. Is it increasing or decreasing? How steep is the line? What is the starting value? And how might you answer those three questions for these two graphs? So that's exactly what we're going to dive into now. So first we're going to look at these graphs and ask, is it increasing or decreasing? So let's take a look at Graph A. I see it with a high value up here, and then it looks like the amount of money I have is decreasing. It's going down with the time I spend shopping, and that kind of makes sense. The more I shop, the more I spend. So this is a decreasing graph. On the other hand, on Graph B, it looks like it's increasing. The more time I spend working, the more money I have. So this would be an example of an increasing graph. So let's take a look here. So we would say that Graph A is decreasing, and a nice sentence that summarizes that is, as time spent shopping increases. As we increase along our x-axis, the amount of money decreases, so that going down. How might we write that for Graph B? So we already talked about that Graph B is increasing, and a nice summary statement. And again, we're starting with our x-axis values. As time spent working increases, the amount of money also increases. You see that we started out at 0 hours with $20. And then here by 5 hours, we now have $60. So that amount of money has increased as we increase the amount of time we were working. Let's take a look at that second question. How steep is the line? So when we're talking about steepness, we're really talking about rates of change. And there's a couple steps to doing it. So first you have to have 2 points on your line, and you're going to calculate the rate of change. And really, I could put that in a few different steps, but we're looking at this symbol here, this triangle. It actually has a name. It's called the delta, and it stands for change. So we're comparing the ratio, that's why it's a rate of change, the rate of change of y compared to the change in x. So up here I'm looking at these 2 points, and here is, we're starting at 80 and then it drops down to 20. So what is that change here from 80 to 20? Well, that's 60. So it's dropped $60 to this other point, right? So we're just looking at on the y, from this point to this point, if we follow it over, how much has it changed by? And it's changed by 60. It's dropping 60. So we put that in here, negative $60. How long did it take to do that drop? So how long between those 2 points? Well, it started out at $80 at 0, and then that next point is at 4, so that $60 drop happened over 4 hours. So negative 60 over 4. So we can say, well, it dropped $60 for 4 hours. If we reduce this and we actually do that division, then we can say, well, negative 60 divided by 4 is negative 15. So we're decreasing $15 per hour. So now when you hear this per, you know we're talking about a rate. So again, we pick 2 points and we're looking at a ratio of the change in y between those 2 points, the change in y compared to the change in x. So we want to do that same thing for graph B. What do you think it's going to be? So I've marked our 2 points here. Again, we want to look at the change in y compared to the change in x for those 2 points. Let's take a look. So I gave you the 2 points, and it's best to use intersect points where it's intersecting on the grids of the line. There's lots of points, an infinite number of points here. But right here at 0, 20 would be the ordered pair for that point, and 5, 60 would be the ordered pair for that point. So just look at carrying that over and just looking at this change here, it's going from 20 to 60. Well, from 20 to 60, that's an increase of $40 on the y. Compared to on the x, it took 5 hours to increase that 40. So our change in x from 0 to 5 is 5 hours. It took us 5 hours to increase $40. So if we divide that, 40 divided by 5 means that we're getting $8 per hour. So our rate of change is 8. And that tells us how steep this line, because the greater this value, the steeper that line would be. Or the lower that value, the less steep, the more flat it's going to be. So looking at the change in y over the change in x gives us how steep that increase is or how flat it's going to be. And our final question is, what is the starting value? So for the starting value, we're looking at when x is 0, what is y? So here, when x is 0, y is 80. So 80 would be our starting value. On graph B, when x is 0, y is 20. So we started with $20. So let's take a look. For graph A, at 0 hours, there's $80. So $80 is the starting value. For graph B, at 0 hours, there's $20. So 20 is our starting value. So that concludes our video today, looking at the 3 questions that we can ask ourselves when we are describing linear relationships. These are the 3 characteristics we want to focus on. So take a minute to make sure that your notes are complete, and we will be spending a lot of time, not just in the next few days, but over the course of the year, really analyzing these questions and getting better at answering them with precision.